everyone. I'm Saurabh Sureka. I manage the software and cloud products as part of the product management team at A10 Networks. And I'm delighted to have with me Tom Guerrette. He's the Solutions Architect Director. We are going to be providing an overview of Harmony Controller, provide a real-life demo, and if time permits, we'll run through some use cases that demonstrate the power of analytics. We have a lot to cover in this session, so please refill your coffee mugs, and let's make it an interactive session. As our customers move to multi-cloud, so does our devices. The devices that Paul and Raj talked about, ADC and SSLI primarily at the enterprise side, and then CGN, CFW, ADC, and TPS on the service provider side. So these devices are also moving to multiple clouds. Security, management, and analytics are the top challenges when you move to a multiple cloud. Harmony Controller provides a central view into the devices which are either on-premise or as part of public cloud. Harmony Controller continuously collects analytics data from all the connected devices, and thereby it provides a comprehensive view into the application and network services for an enterprise or a service provider. Harmony Controller is designed for multi-tenancy, so it provides a self-service portal for application owners that helps them to deploy the applications real quick, as well as it provides the agility required in today's world. This is an overview of the demo that we have today. The Harmony Controller is deployed as a software on standard x86 servers. This is hosted on-premise at our A10 headquarters. We have Thunder ADC for AWS, which is load balancing few applications in AWS. We also have a Thunder ADC for Azure that is load balancing some applications on Azure. We have a Thunder hardware cluster that is operating as a HA pair at our A10 headquarters. And then we also have ACOS running as a container, which is helping load balancing the Kubernetes cluster. So the good part is it provides complete visibility of the cluster in general. And at the Harmony layer, you get to view the entire infrastructure from a central view.
One key thing to note here is that the Harmony Controller and the actual ADCs are front-ending the applications. So the data is going, obviously, from the client through the ADC back into the back-end servers. And the Harmony Controller is collecting metadata from those transactions that are happening. So the actual data between the client and the servers is not going through the Harmony Controller, just bits of data about that, and then that's collected and aggregated. So,
are you getting that? Okay. Are you getting that traffic through the ADC, right?
Yeah, the traffic's going through the ADC.
Through normal routing, or is it going through?
Yeah.
Okay.
It's just a networking device. It's in front of the workloads and.
But it's not doing any like the. I'm sorry, I'm stuck with load balancing, right? It's not going to do any of that. You're not setting up that part. You're just you're putting a bump in the road, right, in order to collect that data, right?
Well, as the traffic goes through it's load balancing, and sometimes a full proxy, sometimes not.
Yeah, it can, but it doesn't have to, right?
It doesn't have to.
Okay.
Right. As long as the traffic is going through, it can send bits about that traffic that's going through up into the Harmony Controller, and then it collects all that and aggregates it, which is what you'll see.
Perfect.
Here.
Can you describe some of the metadata that you're collecting?
Describing there's lots of different ways to send the traffic through the ADC load balancer. So it's just bits of data that's of all the transactions that are happening. If it's a full proxy, we get more, and it'll be apparent when you see all of the graphs and charts that I'll show you as part of what we go through.
So just to answer the question in a bit more detail, so there are means of communication. So for example, we use Kafka for logging the metadata from the Thunder device to the Harmony Controller. Then the question is, what is in the log, right? So we use the Avro format. And what is in the log is there are layer 4 logs, layer 7 logs. Layer 4 logs is kind of like a net flow record, would have source IP, destination IP, and the duration of the connection, how many bytes were transferred, and so on and so forth. So it's like a session log. For the layer 7 part of it would include URL, response code, user agent and response time and all of these different. So essentially a lot of metadata at layer 4 and layer 7. So this is something that we are doing for all the different services.
Thanks. So as the ADC devices register into the Harmony controller, that Kafka bus is set up and run, and it's a live connection sending all of that data. Also, any kind of configuration changes that are done to the networking devices, the ADC devices, will also be sent so that everything stays in sync if there's out-of-band management happening. When the ADC devices are configured, they could be configured different ways. Saurabh showed the different types of clustering we have from the ADC devices, or even which cloud they're in, for example. So I have some examples here. This first cluster is AWS, so it happens to be a Thunder device. You can see down on the bottom that's in AWS. There's a Thunder device in Azure, and others here. So I also have an HA setup. So this one has 2 Thunder devices in it. So as they registered individually or together, they come into the same cluster automatically in the Harmony controller because it recognizes the way they're deployed.
So it would be a replacement for like HA too, right? Is that,
well,
that true?
these 2 Thunder devices down on the bottom are in HA.
Okay. You configure them here, or were they configured as HA and then registered in?
This particular example, they were configured as HA and then registered, but it doesn't matter.
Okay.
Yeah. So looking at this device, of course, I get some basic statistics on how it's set up. I can see which software image is running, how it's set up for VCS, and how to manage it, et cetera, and some statistics on the processing, et cetera. Just by simply clicking on it, I'll see the number of partitions that it has. So again, if some out-of-band management change happened and a partition was added, it would be on the Harmony controller instantly. In this case, I know I have an application running on this tenant. So here I see the application. So this application is simply a WordPress application. It's got a few servers sitting behind it, so I can just mouse over and see the status of them, and then see what's running on the connections through them. Just by either clicking on that or clicking on the graph here, I can do some things like edit that application or view the analytics. So clicking in here gets me straight into the analytics. This can be set by different times, so it defaults to the last time. So just simply sliding across the graph, I'll expand the time of the data that I'm showing that's gone through. Here I can see the first chart is end-to-end latency. So this is what's happening from the client as they access the application. So depending on the network, there's lots of hops in between. I can get a graphic view of that by looking at the time. So here you can see at each hop, for the time frame I have selected, I'm showing the average time for each of those hops. This is really useful for, hey, this application seems slow and sluggish to an end user. What area of that transaction is it happening in? Is it happening, maybe the ADC is overloaded, maybe the network's overloaded, maybe there's a faulty server. It will quickly show me this. And down on the bottom here in this chart, there's actually some different colors here, and each color is graphing one of those hops. So we're only seeing green here because it's in this time frame I have selected, that's the SRTT. It just happens to be that, and I can see it where I'm mousing over there. The time delay is high. So I see a spike here where it even went up higher. And I can just simply zoom in on that. And now I've changed everything to just filter that time slot, and I see the spike more apparently here. All of the rest of the charts and the number on the top changed when I highlighted that. So I can see what's happening here. So at that particular time, the client SRTT is the highest number here. If I want to know maybe what's happening during that time to try to troubleshoot what's happening, now I see client performance, and there's one client that's receiving that. So looks like in this particular case, and by the way, this is live. I have this live on the internet, this application. So this is not simulated traffic, it's live. This client here is sending more or experiencing a higher delay. Could be for a multitude of reasons. It could be that they're sending more traffic or something else. And now I can see that there's a URL. So one particular URL that they're hitting is way more than the others, right? And then down here, I can see all of the individual request logs for that. So now I get a way to filter through what happened during the time frame. And I can zoom into 1 minute. I think I have about 5 or 6 minutes here now. I can zoom that in even more, and then filter this more that way. And there's lots of other ways to filter the traffic. I can look at particular browsers, client OSs, et cetera. And that's really useful for, hey, if this was an application delay, and maybe it's specific to a specific browser or even a version of a browser. It could be many things. It could even be one server of the pool of servers that's having an issue, and then maybe only a percentage of the clients are connecting to it. So you can easily see that just by zooming in here and looking at what's happening. I also get maybe a geography display of where that traffic is coming from. So I can mouse over and see the numbers from each location. So again, depending on how I set up the filters and how I zoom in, everything will change here. And this is for one application as it's going through that ADC device. So that's the client perspective for all of these analytics. We broke down the perspective here into 6 different categories. So you can see these are some of the charts from a client perspective. Number of requests is you're seeing a spike here. And again, if I want to see what's causing that spike, just simply zooming on it. And now I can see where it's coming from and where they're going, and what OS they're using, what device it is, et cetera. And I can also zoom into the logs on that as well, just by looking at the logs. Here, I get something kind of interesting. A lot of failed requests from a single IP going to many different URLs. Kind of looks like an attack or something to me, right? But look how fast I can find that, just by a simple few clicks, right? Because the result of some kind of fingerprint or probe like this causes things to slow down sometime, and then I can find it, right?
So I have a question.
Yeah.
Can this provide application dependency mapping information that I could use with other products to create a whitelist model?
Yeah, because of the way you can filter things down and go into different areas. Yeah, you can do that.
Do you have the chords that show what everything's talking to?
Well, I think that. I guess I'm trying to figure out more exactly what you're asking, but if you're asking about how the application, how the individual users can use an application and then what they're getting to?
No, I want to be able to see a mapping that shows, if someone comes into this web server, that traffic now goes to this e-commerce server, and the exact pathway that is taken within the data center.
Yeah.
That's what I'm looking for.
Yeah. So having the device having an ADC device between each of those hops. So if you're connecting to an application server and then it's connecting, say, to a database server, as long as there is a way to track that traffic in between, maybe another a layer of a virtual server in between the client and the server, then you'll be able to correlate them together by saying the end-to-end application here is this virtual service or this app service plus this app service, and then you put them together, and then you'll be able to see that by maybe filtering on a source IP as an example.
Okay, and one other question. We've seen some very similar products this week. What is the big differentiator for you with Harmony?
So you're seeing all the way that we can collect all of these analytics, and we're doing this without probes, right? This is all coming from correlating things like how long did it take the client to connect to the ADC, and then how long did it take the backend servers to connect, and then what was the entire session, and we add that together and compute all of these numbers. And we're doing it without the traffic going through the controller itself. So we're giving you that. Plus, we can also manage the devices. Right?
So agentless?
Yes, absolutely.
Okay. That is a differentiator.
Yes. So I've just clicked on application here to get an applications perspective. I'm going to zoom out a bit on the time here. So again, I can put any time frame I want, or I can use the mouse to drag and drop over the screens here. But this is showing me the application response time. So this is focusing more on, hey, what's happening on the applications. I get the URLs that are being hit, the domains, each app latency, which ports. Maybe something more important here, the slowest transactions. So transactions are where were all of the connections going as they came into this application on the servers themselves. So I can filter them by latency. So the highest time here, it happens to be this URL. Just click on that and it shows me those logs. Maybe it doesn't exist. These happen to be 404s, which means it didn't connect. This is a client trying to connect to something that doesn't exist. Maybe my application is broken and the client's trying to connect somewhere that doesn't exist anymore, or maybe it's some sort of an attack. right? But the app administrator would know if this URL is supposed to exist or not.
I have a question.
Yeah.
With this being agentless, which is a good thing in certain circumstances, this is still only one spot in the network to measure latency and things like that. So if you find that you have slow clients, do you have systems to augment to help find out where in the path
Yeah, I mean, so
that it's slow from the client all the way to the ADC?
Yeah.
Because at that point you just know that the client, there's slow connections from the client,
Yeah.
but you don't know where in the path that is.
So yeah, and of course it depends on where the ADC is in the path, as you're saying.
Yes.
Is it closer to the client or is it closer to the servers?
Correct. It's still only one point in the network.
Yeah, and in many deployments that we see, let's say it's your web servers in your data center, there's an ADC sort of at the front end, maybe a larger one, and then maybe another ADC doing something more detailed or more granular into the application, closer to the application, and then you can correlate the two of them together by adding the app services together. So that said, the Harmony controller itself is a full RESTful API. So the logs can be exported and then correlated with other systems that might be having that data set from another source.
Okay. Yeah. Thank you.
I want to drill in on this one a little bit to show you. So we're showing you, hey, there's a request log here. If I just click the arrow here, I can get full detail of that particular log and how long that request took, and details on the client's IP, location, et cetera, which app server. This is another very interesting. We can actually show you which app server each request went to here. So, and this will help me find out, hey, is there one bad app server, for example? And also, maybe the source location is the problem, right? Because of something you asked earlier, right? Like if I can correlate and say, from only this source location, I'm getting latency, maybe it's something on the client side or on the networking side from that location.
Do you have something like that for the endpoint servers themselves to show, yes, this particular server is taking longer to respond?
Well, we can show you which servers are taking longer to respond. And so if that information is correlated, and then maybe a deeper detail on the server logs can be, so it's more, let me point you to which server to go look at.
Yeah.
And of course, in the SDN world, if it's a virtual server, if it's got a problem, replace it.
Are you actually running the analytics to do that correlation so that you can kind of alert people to that?
We're running these analytics from the ADC device. So everything that we can get from the traffic as it goes between the client and server is what you're seeing here. We're not collecting logs from an app server. We're giving you the ability to export them because most of our customers would have something that they're already collecting the logs from those networking devices, and this is adding more detail to it. So again, any of the transactions that I showed you, you can get that much detail on all of them. One more thing I want to show you here on this is the ADC service itself. So this is, hey, how is that ADC running? What percent of traffic is it sending to each server? In this particular ADC, on this particular application, I've got 3 app servers. Fairly, it's not. It's supposed to be equal for all of them. So I can maybe take a look at this and say, why is one server getting more than the other 2? Exactly. So it's just kind of giving me a clue to go look at some of the servers here. With that, I can look at the load distribution across them. So this is telling me how each server is doing, and maybe error traffic. So again, I can take a look at how many requests are dropping, how many are getting 200s, et cetera. And then clicking on any of these gets me into the request logs again. If there's some SSL offloading happening, I can see all of that data as well. In this particular example, I don't have that. And then an internet view. So this is showing me app latency, again, via the time I have selected. So I'm up to a week here. If I change this, everything gets updated, right? And I can see where the traffic had some maybe latency issues or just simple throughput and requests. Just kind of giving me the visibility into who is using this application. Let me click back on the infrastructure page here. So let's suppose I wanted to manage this device. Okay. I have all the statistics here. I have a little pencil here. So this pencil will give me a single sign-on directly into the web UI for that device. So here I could make some changes if I wanted to manage this device. So this is for, I'm going to change this application a little bit. And this is showing our web UI. Again, there's the server. The server is here. The services are here. The actual end servers are here. The service group is here, etc. And again, if I made any changes to this, the Harmony controller would know instantly. I think there were some questions about how to connect to the Harmony controller from the device itself. So this is the connection. So once I get the device on the network, a few commands can be either done from the device itself or can be done from the Harmony controller. So there's many ways to get things connected from being start, and we're looking at ways to actually make that even easier by discovering things and having them automatically be connected to the Harmony controller as they're deployed on the network. So with that, I want to show you a little bit of some future things that we're doing. This is another version, the next version of our Harmony controller. And I have a connection into an Ingress controller in a Kubernetes network. So the Harmony controller itself is a Kubernetes application. Many customers that we have are deploying Kubernetes applications. So I just thought, okay, let's show the Harmony controller as an application. Inside of it has many pods and containers or services. So the Ingress controller is installed in there as well, the A10 Ingress controller, and connected to this Harmony controller, which gives me visibility into what's happening with the access into this Harmony controller. So I'm seeing the same thing. I'm seeing the logs as they connect into the Harmony controller. So if this application was having an issue, I can see, I could see it here. Total requests. So here, the requests are normally low, and then sometimes they're high here. So somebody started using the application, et cetera. So you get the idea that there's lots of ways to use this product. Then I'll show you a little bit about configuring it. So the key thing with the Ingress controller is that in Kubernetes, there's services that happen. These services are created internally. Because of the Ingress controller and how it's connected into Kubernetes, it can send RESTful API calls into the Harmony controller and dynamically configure all these services. So when I set this up, I didn't manually set up these services. These are the internal services. That's why the names look the way they are, because these are the services inside of Kubernetes. And each of these services with their pools of servers were dynamically configured here. So once this is set up, I can go in and make some changes here. But this came in dynamically. If I wanted to block a service or change the security policy in one of the internal services here, I can just edit it here and do that.
Does that mean you're heading into the direction of service meshing? Do you see that as a future for your product?
Yeah, the future is anywhere that an application is deployed, we can be there and collect analytics on it and provide the load balancing and security services.
You must love the idea of a load balancer per server. Or per container.
Yeah, and if in the container world, containers are coming up and coming down, and having it be dynamic is the key part here, and that's the whole RESTful API part and the integration in all the DevOps tools, et cetera.
Thanks, Tom. We're going to run through this real quick. There's something else we would like to squeeze in and show. We talked about blame the network game. So any enterprise today has a few hundred applications and maybe a few hundred service desk tickets. So just by using Harmony controller, the time to exonerate the network, traditionally it could be hours to days, but then with Harmony Analytics, it's literally in a few minutes. So let's just run quickly through this demo. You have a service which is provisioned, gradeco.org, and this is true, A10 Hearts NFT. And what we are going to do is we're going to induce a server-side latency by calling a script to just sleep for 5 seconds. But in real, what if this was really application-side issue and there were some latency issues to be blamed on the application developers? And obviously, we know latency is quite a thing. So what we do is we go to the per app analytics dashboard on Harmony. We click on that. We look at the parameters, the device parameters, and then we do this on a per URL basis. And you can see here that there's the sleep5.pl took about 5.2 seconds, spent 5.2 seconds for processing. And when you expand on that, you get this nice view, which will show you that the real latency was in the app server side, on the app side. So there you go. You can easily integrate this into your service desk using REST APIs and open a ticket and blame it on the application guy. Another use case is pinpointing attacks and then distributing policy, which Raj talked about, across a multi-cloud deployment. So in this case, we are running a simple ping. HTTP ping, application level ping. And you will see that we can easily flag such a situation in Harmony by going again to the Per App Analytics dashboard. You will see that there is a spike in the request count for that particular time period. And if you look at the specific, if you filter by client IPs, the top request is coming from this specific IP, 182.156.236.26. And what you can do now is you can compose a policy to block this bad actor. Not only can you apply this on this specific device, but you can deploy it in a multi-cloud deployment by a single push. And this can be easily automated. Here what we are showing is obviously HTTP ping attack, but then think of it as anything that can be going on the network. So with that, this is going to save the script and then push the script to select the devices we want to push it to.
That's pushing that script out. That's
Yes.
pretty awesome.
Yeah.
Yep.
Yeah. And then you will see that you get a 403 for that client, and you will see a similar response. So all the traffic is getting blocked at the ADC level. So with that, we do. So what we showed here is specifically to ADC. The real power and the differentiator for Harmony is to have that universal view across all these services. And we have a short demo that will demonstrate how Harmony can be used to look into a CGNAT deployment. Tom?
Yeah, right here. So this is first time we're showing this. So this is live, and again, this is with our next version of our Harmony controller. So we're giving you a sneak peek into this, and this is where we're having loadable applications into the Harmony controller to expand the capability it has without upgrading the version of the Harmony controller. So here, in this example, carrier grade NAT is running. So this is a screen showing the dashboard of that. Lots of different ways to configure NAT, and so simply selecting the 6 to 4, 4 to 6, or the type of NAT it is, you'll switch over to the configuration that is doing that. And then you get, as you can see, statistics on throughputs, packets, subscribers, et cetera, on that. And then just by clicking different types of the NAT, you can see what's happening there. So we also have the analytics of this. So simply clicking on the analytics on top, we'll switch over to that, and then you can see statistics and information based on the subscriber or the destination, and even the NAT service in between. So we just wanted to give you a sneak peek of this and show you that we're going to continue to add functionality into the Harmony controller to cover all of the services that we deliver at A10.
Can we say 5G? This is a 5G thing?
Yeah, I mean,
It's a pretty consistent theme over the last 3 days. We've seen quite a bit about 5G. This looks to me like I could use the A10 for load bal. I can use it for DDoS.
Yes.
I can use it for security monitoring and stuff. And carrier grade NAT, I can spawn an instance. Boom, I've got a new tool.
Yes.
Same product.
Absolutely.
Different use case.
Absolutely.
Okay.
So I've got a question for you, because I work a lot in the carrier space. And one of the challenges that carriers face, whether it's in North America, Europe, is compliance when you're doing CGN, because if somebody does something naughty on the internet, you have to be able to say this person held this IP at this time, so that it can be used in a legal framework. So it's something that carriers struggle with, the analytics of how to, how do I report on that? And it's been very archaic up to this point. Is that a problem that this could potentially solve? Is to help with, in the United States, it's called CALIA reporting, and that's something that we struggle with.
So it's a good question. The primary focus of this presentation was on enterprise side, but it's a carrier question, so let me answer that as well. Yes, this is our intention. On 5G, we have a solution. We call it as 5G GI LAN solution. And what we do is that we are focusing on two things: consolidating all the GI LAN functions, including CGNAT, traffic steering, and then application visibility, etc. And then we are also adding security, not only for the GI LAN, but also for the EPC, using GTP firewall and other SCTP type filtering, etc. So all of that is something which we are shipping, and we are actually aware of that. Coming specifically to your question, So yes, compliance is one of the big problem we see in Career, and that our intention is to solve it through this. Now, you asked a very good question, Kalia reporting, and Kalia is, in CGNAT perspective, from our perspective, the way it works is that you have an internal IP which gets translated to an external IP. If a user does something bad, a server will just give you a translated NAT IP. You will not know who the user was at the time.
Right.
So that is something when we log our systems from our CGN appliances, when we log, we give you that log, and this system will be able to give you that correlation. So that's our vision on this one, on this particular system. The other problem we are seeing emerging, and again, this is on the European side, EDC already has this requirement that IPDR data records is something which everybody knows what they are, and you're mentioning IPDR. But then in the world of WhatsApp and the world of IP calling, if somebody is communicating with someone on one of these IP protocols, you will not know. So traditional IPDRs will give you the IP, the actual phone records. But if I'm not using phone, if I'm just using WhatsApp, that is where you need some new mechanisms. So that is where our GI LAN solution or 5G GI LAN solution will have a big role. And in that case, we are going to be detecting application, source IP, internal source IP, translated IP, etc. at the time. And we give you a simple log message. We log that and we show it in the system and perhaps in others as well. So that's the vision.
Okay, great, thank you. So I've got a follow-up question to that. So architecturally, I could put a carrier-grade NAT gateway into a POP or a data center, and then the Harmony controller can sit in the cloud so that I can have those analytics for, if I might need them for the carrier. Because I think that's a great solution. Like you mentioned, the correlation is really, really difficult. It is a really hard problem to solve. So that if you have data analytics that makes that correlation for you, that's a big win.
Right. So it's certainly a big win. It's not only in the cloud, but also on-prem. The other big important item on the analytics, the problem we see is the amount of log storage and the amount of logs which you need to consume. The incoming rate is critical.
It's staggering.
Exactly. So our vision on that is that we are going to be enriching the logs as soon as possible at the earliest point so that we can reduce the entire pipeline. Instead of sending gigs and gigs of logs out, we'll just reduce that size. And that is where we can do enrichment on the box itself, and we can give you that visibility.
And so then you can archive those logs for compliance to whatever storage medium you choose.
Precisely,
okay.
Yes.
Yeah, one of the very exciting things that the Harmony platform is able to do, Saurabh mentioned it and Tom mentioned it, is the ability to actually dynamically upload new apps. So it's really a platform which is very extensible. So what that means is very, very interesting. So today what is happening is Harmony is collecting logs from our devices, correct? Now there are also third-party devices, let's say F5 or Citrix or some other, Now that will go into Splunk or LogLogic or wherever it may go. So we can add apps. And this is something, one of the use cases will be demonstrating Office 365. But we can add an app onto Harmony, which actually displays logs from any third-party system onto Harmony. And that way you can get any kind of correlation, whether it was natively provided by A10 or not.
Okay.
That's something very exciting that we are doing with Harmony.